Yeah. Morning, everyone. I think it's time we get started. Yes. I hope you had a you had a great night yesterday. I hope you are in your senses. I try to avoid all math because who likes math? No one likes. Like everyone wants magic. Like you want machines to translate images into text. Like there are 2%. Has anyone checked like what Facebook images alternate text is? It will tell you how many people are there, where they might be standing and stuff. Yeah. So here, my whole idea of this presentation was about a progression that I have gone through, trying to do some stuff. At the same time, I try to keep it in the most abstract way so that you don't get confused. Because there is no point in me throwing a bit of math at you. That doesn't really help. The core concept is you have to get the essence of what's happening inside, right? Then maybe you can apply it in whatever field you want. So this talk, it's a fancy title, but the actual thing is what works and what doesn't work. It's not necessary that everything works, and it takes some effort. I am Bharadwaj Machiraju. I graduated 2 years back. I work as an application security engineer. I used to love machine learning. I'm project leader of one of the OWASP flagship projects. If you want, you can follow me on Twitter. I don't tweet much, but yeah, maybe here and there. So this is kind of disclaimer. The first thing is, I am the only one doing this alone, right? All my research is whatever, it's done by me over a period of time in my free time. If you find something can be done better, please come over. Perspectives help. I have other perspectives, but I really want some domain knowledge people, yeah? Whoever I talk to are more like ML, PhD stuff, and they tell me ML stuff, but yeah, domain-specific knowledge helps. I also tell where I failed horribly, yeah? Because so that you don't waste your time. I probably spoiled 2 or 3 months trying stuff. It's fine. You try stuff, you fail. I tell you what I failed at so that you don't have to repeat the same progression. So how are you going to progress is, first we'll look at what are we trying to achieve, right? Just leave the rest of the stuff, it doesn't matter. So, as I told, the main objective of this talk is to convince you that ML is not rocket science, yeah? I hope most of you already agree with me. ML is good, yeah? And maybe try to convince you to work with me, or maybe try to convince you to contribute to my stuff, or let's build something cool. Like, we have to move forward, right? What's the point of staying in the same place? Let's start with a story. So, once upon a time, there is a school site called GitHub, yeah? And it announced the swag bug bounty program, where it will give out free t-shirts and stuff, yeah? So, you started testing that. So, first you go onto the page, yeah? And then you try to sign up, because you're going for the first time. And then you go and log in. You come across a repository. You go click some stuff, do your regular pen testing stuff, like click here and there, try to manually edit here and there. And then you arrive at some other repository. Will you do the same things again? Technically, you have did some testing for the repository, the core Linux repository, and you arrived at a different repository, but will you do the same testing again? No. Why would you? You have already done that. Like, yeah. This is more or less how a pen testing approach works, right? You sign up, log in, whatever, you go in, you test for stuff. But let me tell you what's the most beautiful thing that skips. Like, we have become so automated that we do these things very quickly. There is a beauty that hides in these steps. The thing is, first of all, how do you know why to sign up? Like, why? Why sign up? Why log in? Because you have been told or you experience that the attack surface increases when you get more functionality, right? And your sign up login sequence is a way towards that more attack surface, yeah? So you subconsciously memorize that, yeah? And the second thing is inputs. Like, how do you know what an email is? For the first time, someone might have told you, right? Someone might have told you, okay, this is an email. Or you might have learned yourself, okay, I think this looks like an email letter. I think this is an email. You learn, and you don't forget, you remember, yeah? And then you understand the feedback by the application. For example, it's saying that your password is not supposed to have a uppercase, whatever. You are understanding the feedback. Like, it's not necessary that you put the first thing, the correct first thing, yeah? You'll get the feedback. Are you getting the beauty of what we do so subconsciously? Like, we just pick up hints everywhere and we're just flying through, yeah? And recall input values, it's basically like, yeah, once you sign up, you're like, okay, login is asking what we have already filled in. It's not something new. You don't try to sign up using login, right? Like, from a perspective. And then categorize. It's basically the same thing. Like, you have, like, let's say you are bug hunting on Amazon or something like that. You tested a product page. It's not that you'll go to a different product and start testing all over again. You tested a product page. How do you classify? Like, all these beautiful things are automatically done by you, that we have become very efficient at what we do. But to teach a machine all this, it's a different story. So you have to go a step back and try to realize all the minute things that you keep doing that take you forward. And yeah, the redundancy is the same thing, like you categorize and then you don't do the same thing again. So if you classify those 6 things into broad categories, this is what comes up. Yeah. So if you want to take the help of machines in doing what humans subconsciously blaze through, these are the 3 things that your machine needs to excel at. First, they're supposed to identify inputs, right? The second thing, they have to understand the feedback. That is the most critical thing. It's not necessary that, let's say you have seen an input that you haven't seen before. Yeah. Applications provide input. They are just, no one says you, dude, you are wrong. They tell you, dude, you are wrong because this has to be corrected. Yeah. If you have machines that can understand feedback, those are truly self-improving machines. Yes. And the third thing is sequence. Yeah, we'll look at it. You'll understand. I'm sure most of you can I have a quick raise of hands of who have a basic idea of what machine learning is? Okay, for the greater good, we'll just slide through, okay? Because it's necessary, or else you must skip it. So this machine learning can be, so we're just talking about machine learning now, not artificial intelligence, yeah? So machine learning basically is nothing but curve fitting, yeah? Curve fitting, nothing. You have some data points, you try to fit a curve. If you don't get it, fine, let's wait. So that a function written over there is your machine learning model, okay? You give some input and you want it to give you some output. Let's get to an example that will tell you. So for example, let's say you are running a Fitbit competitor, yeah? The whole point is you have the data of pulses, human pulses, yes? And now you have to count steps. That's the basic thing that an activity monitor does, yeah? So your model is supposed to be something like that. You feed the model function data, pulse data, and it is supposed to tell you how many steps it is. Very simple. The whole point of machine learning is you don't have to hand code that F function. The machine is supposed to learn it. Yeah. This is the sample data. Can anyone guess what, like there are 1, 2, and 3 steps. Can anyone guess what are those different things? Like this is pulse data for sure. Can you tell me which one is 1 step, which one is 2 step, and which one is 3 step? Those are simple pulses. It's very simple, yeah? 1, 2, 3, exactly. How did you tell it? You have the innate knowledge that when you walk fast, either the amplitude increases, the height, or the time reduces, like your heart will beat, it'll be faster, it'll be quicker, yeah? Did you use anything else? No, probably those 2 features help you, right? So, you picked 2 things subconsciously, and based on those 2 things, you decided that, okay, this is 1, 2, and 3. This is called feature engineering in machine learning. Fancy names, but it's basically the same thing. You take the features that make most sense, that have most variance, or that that actually vary, yeah? And then you feed it. So, from the previous example, here now we have modified that. The new step, we won't feed the entire pulse data. We'll just feed in the pulse height and the pulse distance. I think that's good enough, right? Just two inputs, that should be fine. I hope you understood what feature engineering is. It's pretty simple. Get the core. Why shouldn't you give feature engineering to machines? Because they don't have the context or knowledge we have, yeah? We are like more than 20 years of living in this world. We have become pretty good. I tried to plot it. This is done by a guy. So when you plot it on a 2-dimensional graph, this is more or less how it looks like for different age groups. Okay, don't tell me why this is not in a linear view or something. It's for different age groups basically. So just for the sake of brevity, you can see that all the green ones are 1 step, blue ones are 2 step, and orange ones are 3 step. What is your machine supposed to learn? The boundaries. Yeah, your machine will learn your function when represented will actually be something like that when you plot your function, when you model. So whenever you get a new data, you feed your function, it will tell you. Done? Are we ready to build a competitive Fitbit then? Yeah? So what we just did is called supervised learning. We told the machine that use these two things. We gave it a bunch of data saying that these are 1 steps, these are 2 steps, these are 3 steps. Now try to understand what you can, right? And whenever I give you a new thing, do the same thing with that. Try to plot it. That is machine learning in a crust. I hope every one of you got a sense of what machine learning is. It's not rocket science. There is another variant of machine learning called unsupervised learning, where it's more like you don't tell the machine exactly what to. Feature engineering will still be there. It's not, you won't give it labeled data. Like you won't tell it, okay, these are 1-step pulses, these are 2-step pulses, these are 3-step pulses. You just tell it, dude, this is the data. You'll put it, given the features, and let it figure out. How does it work? Consider the same problem. Yeah, the same plot, this plot. Now if you tell a machine, try to categorize this. How can it categorize? Isn't it? If I don't show the colors, you'll be like, what? Yeah? So there are ways in which you do unsupervised learning. That is, you tell it the kind of cluster you want, the type of clusters it is. So basically you visualize how the data points might end up. You have to tell it that I need 3 categories from this data. I need 4 categories from this data. Like in our example, we'll say I need 3 categories from this data. So 1 step, 2 step, 3 step. And you'll tell what kind of pattern it might be. What's the difficulty in this? It's very convenient considered to supervise because you don't have to label lots of data. But it's difficult to visualize when you go to high dimensions, right? Tell me, how will you imagine a 4-dimensional space? I don't know. I saw a YouTube video of some young guy explaining. I couldn't understand basically. It's crazy. 4 dimension is very less. When you talk about machines in big scale, right? You have 1,000 dimensions, 10,000 dimensions. Oh my God, why? We just cannot visualize. It doesn't mean unsupervised learning is bad. It's nice. But in some cases, just like everything in life, some things are good for something. Well, the whole concept of breaking down web for machines to learn boils down to this, the problem of text representation. Is text our only option? But tell me images, but then site interfaces change. Imagine this from a perspective of a single employee working in his free time who doesn't have any GPU, less time, no data to collect, no one funding me. Text is easy because text is what that communicates between the application and us. Yeah? More or less. There are other ways of doing it, but I found text to be pretty easy because, I don't know, maybe partial. It's primarily because I could understand the feedback what the application was giving back. Yeah, maybe you can just say I tried to replicate what we do. Simple. So why is text processing hard? Can be explained by these 2 lines. I picked this from a Quora answer. It's so nice. If there is a text called pressing a suit, and if a lawyer and a dry cleaner reads it, it means 2 different things for these 2 different people. Yeah, it doesn't mean the same thing. You know, we never understand text that simply. Subconsciously, we do lots of context processing and lots of things, and we just understand it. It's so beautiful, but the whole reason NLP is so hard is this. Context, basically context. Then, now we understood what's the problem of representing text, yeah? And you also know that the functions or models that we develop actually take in math. They don't take text. They need numbers, yeah? So the first challenge, if you remember the 3 things that we have, the first thing is that we actually had to identify the inputs. Yes? Just a bit of lingo. So labels are anything like that. A placeholder is basically what defines the input, right? For example, like for there it's written phone or email or full name or those are the placeholders. I call them placeholders. Yeah. It's basically derived from the HTML5 specification. Simple. Attempt 1. How to get it? I was like, okay, supervised learning for the win, new boy in the town, let's get some data, let's hand label it. Nice, but to label everything it takes a lot of effort. Yeah? Imagine on the scale of web, just imagine on the scale of Alexa top 1000 or something. The amount of placeholders that you can get is humongous. Yeah? Supervised learning works, it's simple, not really effective. Yeah? After labeling, I was like, oh no, this is going on forever. What will I do with this? Then I was like, okay, I think I need more data. And who are the best people to learn data from is humans? Yeah. So I got hold of a bunch of my friends. I wrote that, dude, you have to install this extension called Tamper Monkey. I wrote a user script for this so that whenever you fill a form, it gets converted into something and I get your data and all stuff. So whenever a human fills a form, whenever a known human to me or a close friend to me fills a form, I get the format of what he's filling and the placeholder. That is the way I started gathering data, because I was a single man. How long can I browse? Even if I had automated the crawling part, filling part, how would I know? Even it again boils down to hand labeling all the stuff. Yeah. So I was like, okay, let's give some extension stuff. And I started getting data. It was nice. For the first time, I had lots of data. Data is money. If you have no idea, data is actually money. I started getting data. I started getting really nice data. But I used to anonymize, or what do you say, randomize the thing at the browser itself so that I really don't get the actual things. Some people were pretty scared, but I really thank those people who installed the add-on, very close friends. It was nice. It felt nice. But then the problem was, I was getting data, fine. What will I do if I get a new string? For example, now I have lots of data. Okay, I have every placeholder in the world basically, maybe. I have the corresponding suggestion to it, yeah? But then what if I get a new thing? How will I compare these two? Do I again have to go back to the data, find, select query on all the email addresses and label them again? No, I was done with labeling. Let's do something that was taught in engineering maybe, called vectorizing. So basically, vectorizing, this process that we are doing is converting text into numbers in such a way that similar texts are placed in a similar place. Yeah? For the technical people, I used TF-IDF because it works, because it is good. Doc2vec and all, it's an overkill. Anyone who didn't understand the past statements, just ignore it. It's for the technical people. So the simple thing was, I wanted both these vectors to stay close in the space. Yeah. So when you visualize it, it turns out like this. The dimension is much higher, but I actually reduced it using TSNE and brought it into 3 dimension. That's a cluster of placeholders. Can you imagine how many placeholders are there? It's over 5,000. Yeah, but okay. Let's plot it in 2D and see. If you can see here, see, the email addresses are correspondingly closer. The passwords are together. When something is, see, for example, this one, there is username or email address, it's the placeholder. It's equidistant from the email and the username. You see? You understood what I did? Nice. Cool. So when you do that, you did a very huge task of converting text into numbers. Now it was simple. All I had to do was, whenever I get a new placeholder or something, I would just plot it into the same vector space and find the nearest matches. Yeah, I would get a suggestion. So basically this is, okay. So this is how, it's a module of one of the framework I wrote. So this is how you import the module, and then you start guessing. For example, you can type whatever placeholder you want. If you see here, the first 10 are the best matches, like 0 distance from the place. And the last 10 are the farthest from that. Yeah? For example, it doesn't matter what you do. Let's say email, you'll still get, see. So basically you have a bunch of places, things to see. Like for example, all these are closest. Like the perfect thing email is the closest match. There is one more that is very close. So based on the distance, you will pick whatever you want. For example, there is something like card. Okay, name on the card. It can be anything. Huh? See, name on the card, credit card number, credit card number. Those are the closest matches, and the farthest matches are 1. 1 is very bad. Okay, 1 is no. We're not going to do that. Let's try debit, credit card, debit card, whatever. The best thing I liked of the best thing I can show you for this is this thing. See the number of date formats that you can have basically. Can I really individually get all this data and label all these things? No. Yeah. You got the essence of what we did, right? We gathered data from huge number of people, taking inspiration from what Autopilot does. and then we just plot them into a vector space, get the cool stuff that we want. Why lots of matches and why not just one is because you never know what is for the right thing. We'll get to that point later, how we solve that. But yeah, basically you have a bunch of choices you can try. I think it makes sense. Yeah, it kind of worked. I was pretty happy with the results. Well, the next thing that we have after the identification of inputs is understanding feedback. Yeah, how do you understand the feedback? It's very innate to us that we just understand these things. Okay, username, yeah, must have 6 characters maybe. Password, yeah, it should be complexity, blah, blah, blah. Password, something, something. We understand these texts very simply. Can you tell me, can you guess a way where I can actually understand this sentence? We are talking about understanding the sentence itself, the meaning of the sentence. Yeah, NLP is a big thing, so what can be done? The most simple, so NLP is the process of dealing with the entire text, the text itself. That's the only field that we have for processing text, I think. Let's go back to engineering. No, school. I think school should be fine, right? Parts of speech, ring any bells? Adjectives, nouns, stuff, yeah? So, can you just decode that? Like when you say 6 characters, what is 6? What is characters? So you can just do parts of speech tagging on a sentence and try to understand what it is saying. This is the very bad version of how a pause tagging looks like all the fancy stuff. But let me show you here. So I have a bunch of text over here. For example, one of the most complicated things I feel is this. Your password must be at least 8 characters long and contain it and 1 uppercase letter, 1 number and any of these special characters. I basically convert it into a vector using pause tagging and some custom code, and then I get the suggestion. Yeah. Now, let's say I found an input that I don't know previously. I try to understand, put it back into the database. See, we're going in the right direction, at least that is what I feel. Like, whatever we're not seeing, we're adding to our knowledge base. Like, okay, cool, let's take this. The main problem with this approach is, if you remember the last one that we did for identifying inputs, it was language independent. Like I can give the add-on to 2 Spanish guys, 2 Italian guys, and I'll get Italian data, and whenever I get Italian placeholder, I just vectorize it and then get a suggestion. The problem with pause tagging is it's very language dependent. Yeah, that was the problem with. So whenever I try to achieve something, I want to minimize the effort. I'm bum lazy. No hand labeling, no such stuff. And I want to think it at a scale where it works, but doesn't require much of my attention. Yeah. And one more problem that you generally see here is, here for you, you'll understand that, okay, username must have this, and you related that, okay, that must be username. For a machine that is just looking at the page, how will it understand that your password, the help that is there, is actually belongs to password or username? Again, pause tagging comes into help. One is the noun reference, as I call it, or basically what happens is, when some of the help text you have saying that your password, your username, your something, password, username, something, help text. So when you do a noun reference, you'll get that, okay, it is referring to a placeholder somewhere, and you'll find that, okay, we have a placeholder this. That is one way. The dumbest way that I think I did was, another substitute for this, if this doesn't work, just take the input, right, put it 4 times around the box, you find any text within that area, most probably it's help text. Not all the cases, you can have all the errors at the top, but no one is building such interfaces now. It's very clumsy. For example, you have a huge form, you're filling the form and all the errors on the top, how will you fix each of them? You have to scroll up, come down. It's basically against the basic UX that you teach. This works, this worked. The next thing, this was okay, but it was very language dependent, so I was like, no, not really what I am aiming for. Something that needs to work for everything. So what I did was, this is an ongoing work, anyone who wants to talk about this can talk to me later. It's basically using a recurrent neural network, right? It's called sequence to sequence. You put in a sequence and you get out a sequence. Google Translate is kind of dependent on this, got it? You put in a sequence. So what they did, the most noteworthy accomplishment in this specific thing was, they were very successful in converting English to some other language, translation tasks, right? But for that, yeah, whatever language. So basically they had bunch of text, like huge amounts of text. Like for example, translated books, let's say. They took one book, fed sentence by sentence, other book, tried to tell the model that this sentence maps this. It's long vocabulary and shit, but still, it works. It's called sequence to sequence. It uses recurrent neural network using neural network called LSTM, long short-term memory, right? The problem with this training data, which is what I'm still trying to collect, because when you want to train a neural network, the amount of data you need is pretty huge, yeah? I would really love if some of you might install that add-on or something. It feels nice. AI, machine learning is done. I hope you got what I wanted to say. The core thing I was aiming for, I hope you understood what machine learning stands for. It's simple, and how it is applicable in application security domain. Now here, we are at reinforcement learning. Reinforcement learning is probably the best thing I can explain. Why? It's very simple, it's very easy, right? How it works is, the whole concept of reinforcement learning, it's a part of AI. It was defined from human behavior, yeah? For example, as a kid, I saw an apple, I crawled up to it, I took the apple, I took a bite of it, and it felt nice, yeah? The next time I saw another red thing, which was basically fire, but from my past experience, I was like, oh, red thing might taste nice, let's go there. I was like, go, put my hand in, oh, burn. Will I do the same thing again? Why? Because my past reward was negative. I just shifted from a story into math. So basically, my experience was not good. I didn't like the experience. You can call it in terms of reward. We tend to do things that give us positive reward, or positive, it's not positive negative psychology, it's more like what we feel good. Do we feel good running? No, we won't run. Do we feel good sleeping? Yes, we will. See, we tend to do things what we like more, yeah? And we get these things over time. Is it this way all the time? Or someone might, okay, did you ever fall from a 12-story building? Then how do you know, how do you know that you shouldn't jump from a 12-story building? Because you jump from a bloody step or something and then it hurt. And you're like, okay, relatively this is much big, I might not even make it down, yeah? So it's not just the experiences that you face, it's also the collective knowledge that you have, yeah? For example, playing outdoors is fun for me, so I used to play a lot. But then I tried doing it inside. My mom was like, yeah, it's not a good idea. So these things teach you stuff, what you are supposed to do and what you're not supposed to do. Though the entire RL domain can be just simplified in this. So you have a state, you interact with it. My state at this point, if I'm a reinforcement learning agent, is the entire thing. If I'm, so the positive thing that so what will be a positive reward for me is I learned from seeing other talks and stuff, right? If I give a good talk, it will be fine. You'll be like, okay, cool. At the end, claps, which is a positive reward. I know what I'm not supposed to do. If I just leave it and just walk out, you'll be like, what a hole, right? So yeah, that's a negative reward. I ruin my reputation, everything goes for a toss. So I know what not to do, and I know what to do, yeah? That is more or less RL. So the three basic things that come in RL is, you have a state, you have an agent, the agent interacts with the environment, and the environment tells, okay dude, this is the new state you are in, this is the reward you get for your past action. And then the agent will be like, okay, this state, okay, let me do this then. Then again, he does something on the environment says, okay, this is your new state dude, this is your reward. Cool. Let's take a very simple two-dimensional problem. This is a maze solver, yeah? So in this, let's say the agent is starting from the start. What are the actions it has in every possible state? It's just left, right, up, down, yeah? Done, plain. The reward, let's say, we give it +10 when it reaches the green stuff, and -1 for every step. The core rule in reinforcement learning is, you don't tell the machine how to do it. You will tell it what you have to achieve, right? You will tell that you need to be in the +1 box, dude. That's it. You figure out how you are going to reach there. I'm not going to tell you that you have to go 3 left or some right, something, yeah? That is the usefulness. Like if you tell everything, then what's the point of RL and what's the point of the talk anyways? So how do you define state in such environment is, you will tell the agent that on your left is a wall, on your right is an empty box, on your head is an empty box, and something, yeah? If you tell it like that, maybe it might make sense, right? So that it might know where to go. After bumping into walls, sometimes when it gets negative reward, it will be like, oh, sorry, then Yeah, maybe I shouldn't go there. So it'll try to find the empty ones. Got this? Can the previous state solve the same problem? I mean, effectively. If you only tell the box what its 4 side squares are, will it be able to solve this effectively? I want to collect both the plus ones basically. Your state modifies, like your state changes now, the way you define state. It's basically, you add one more feature to it saying that, okay, what is the direction of your nearest plus one? Yeah? And then it will eventually learn that, okay, I think this one is close to me, I'll go get it. Once it is done, it's like, okay, my nearest plus one is in the up direction. Oh, there is a wall. Maybe I can go around it. Got that? So depending on your representation of state, your genericness improves. Yeah? This agent trained in this maze like this can solve the previous one very easily. Yeah? But not the other way. This is basically RL. So you tell it experiences and it learns. Purposefully, I avoided all the math possible. There are links at the end which you can just click and read the math. Math is boring. Yeah. How will you remember all the experiences that you learned? It is done using a thing called value function. It's not done in a DB, sorry, because it's all numbers. There are better ways to represent numbers, right? Yeah. So it's a value function. It can be stored in multiple ways, and it's extremely boring. And it's one of the most painful parts of RL, trying to find the right way to represent a value function using any function approximator. Too much math. So what we have learned is, using reinforcement learning, you can get some feedback and learn what are the most beneficial actions. Ooh. Our last problem, sequences. In a normal scenario, in a regular web scenario, the most common sequences are basically either link clicks or form fills. Yeah. Tell me any other way you interact with the main application below the line of trust, not your URL bar and stuff, in the interface. It's either clicks or filling something. Those are the only two inputs your laptop has, as far as I know. Oh, don't go into that VR stuff and all, that's different things. So let's go back to our story where we did the sign up thing, right? Yeah. And we picked sign up initially. Why? Because yeah, we had a positive reward from the past experiences saying that sign up was good. So, but how would you represent this state to a machine? For you, it's visual, textual, everything. How would you represent this state to a machine? How will a machine see? How to show this the best possible way to a machine so that over time it gets that sign up is your nice thing, the other thing is bad. Again, we have to convert all the text into numbers, try to make some sense. Yeah. So what we saw in the state for the maze solver, we might have to convert into a similar state space. Yeah. My first attempt was to actually use a fancy algorithm called doc2vec or paragraph to vec, which is very nice. Take all the links and make a vector out of it. Yeah. For example, if you see here on this Twitter screen, you have lots of links and a login and a sign up button. So basically, my state space was take all the links, right? And then take all the form placeholders if there are any, and take the label values. Label values is your session basically, like do you have a username credential or a password credential, and then convert it into a vector. It converts into a vector like this. If you do it the second time after having an account, you have label values now. Oh. You have label values now, and the vector changes. There is a very slight difference between these two vectors, if you see. Just see the first one, 2, 3, 4, 2, 3, and the second one is 2, 5, 1, 9, 2. So basically, it's a very minor difference. Yeah, we'll get to the problem. So this is how I actually trained it. Basically, that okay, you get a reward whenever you log in. Now just try and go and click links. Fun. So basically, what I did was, there is this DOM. I selected n links and m forms, n number of links and m number of forms, and some label data. Put it into an algorithm called doc2vec. Convert it into a vector so that the near ones are nearby. I put it into a value function. I get the most profitable action or random action for acceleration, doesn't matter. But then I perform the action, I get the reward, I update my value function, and the process repeats. Do the same thing again and again. Did it work? Yes, it did. But the problem is, can you identify the problem areas here? The one thing being, one clearly is that n links and m forms, like that is very restrictive what I feel. Like if you just take few number of links and few number of forms from a page, what about the rest of the things? That's not really effective, right? You have lots of sites. If you want to be generic, that is crap. What's the other problem? The other problem is, I'll just show you, maybe with this thing, you see this space, the vector space that here, it's a continuous space. For example, you can have any values between -1 and 1. That's hell lot of numbers. Can anyone tell how many numbers are there between -1 and 1? Exactly, infinite values. Now imagine a function approximator trying to solve that. Can be done, but I am not Google. I don't have infrastructure and stuff and data. So the problems are basically these two things: the representation itself and the form link. So how can this be solved? How to solve this thing? Already we are taking a subset of links and it's giving us bad vectors, and I mean a continuous space which is difficult to train on. The solution was to change the state representation in a way that, okay, let me consider all the links and all the forms, and let me pick what is good, what is useful out of all those, yeah, and then use that to represent the state vector. So the only thing, so what happens with this is, when you do selection using any supervised or unsupervised model, you get a discrete state space, because the things that you're looking at is very limited, so you can just make it discrete. So the updated way of training it is, now we have to train one more selector adding to that RL. So this is more or less the complex algorithm that you can use to train. So basically what I did was, you put a feature selector in there, and then the same thing repeats, but your problem is solved. Like for example, you have all links and forms here, and you have a discrete state space which is easy to train on. Yeah. So let's see what the feature selector does. You give it everything. It tries to pick whatever makes most sense to it, and then it converts it into a form. For example, here it found that, okay, there is one sign up form, there is one sign in link, and one sign up link. So basically it knows that these are the link. When I say labels, these are not handmade labels. It just gives random number to each unique thing it identifies, and it found that, okay, I think there is 1, 2 type of links and 4 type of form. It can be anything. From its experience, it understood that, okay, maybe I should just fill 4, I'll be in. Yeah. This is simpler to train. Then the next, that was good, but the main problem was convergence. Think of a site like Flipkart or Amazon, and I ask you to log in. How many products are there on the first page? How will the feature selector select what is useful? It can go on for days. It went for 7 days, and it found that maybe I should go into trimmer section and find a trimmer. That is what it found. It was very disappointing. Like, that is when I started labeling machines as dumb. Maybe I was dumb, because I expected it to learn 20 years of my experience in 7 days. Yeah. So what I did was, I told it once for one site. Yeah. And then for once I'll do the sequence saying that, okay, this is the login, this is the thing, and then it keeps adding, okay, oh, this is a form. I think I should look for these everywhere. This is a sign up form. I should look for this everywhere. And next time when I put it on Flipkart, it was like, whoa, there is login here. I think, will that work? Oh no, we don't have credentials. Go. Oh, it seems like a sign up. Is it a sign up? Let's try. Oh, it's not a sign up. Remove that feature. Again, go back. Try for a new sign up thing. Oh, it's look like a sign up form. Oh, I succeeded. Let's store this transaction. Let me memorize it. It'll be like those kid who writes, when your teacher gives you to write 100 times, right? This RL will be sitting there and like, okay, sign up, fill in, login, done. Sign up, click, fill a form, go back, login, click, login form. Again, this thing. But the best thing is they can keep going on forever. Within 3 hours, you could get a convergence with this approach. But it's a semi-supervised approach. So first you tell it for 2 or 3 sites, and then it uses that seed knowledge trying to get more things. What is the whole point of explaining this idea in login and sign up sequences? I'm not sure if you realized it is one of the most complicated web sequences that you'll ever follow, because it's hell complex. Like adding an address and editing is very straightforward, let me tell you. It's very easy. Sign up and login is a different story. So you add an entity, edit an the sequence can be called as adding an entity and editing an entity. Yeah. So how do you train this? Manually you can do it, but one of the better ways I found was, we have a company test suite that runs the place where I work, Selenium test cases and stuff. Yeah, I'll just install the add-on there. It'll get all the training data. So we have the seed data, and now we'll be like, okay, bring it on. Since it's the same company, more or less, most of the products may be seen. I was like, cool. I can crawl basically. I can go here and there on web. I can behave around 80% like human. That's good enough. Nowhere above 80%, I can tell you. 80% is good enough for me. I mean, good enough if you are not, what do you say? If it's not a mission critical infrastructure kind of thing. 80% is very bad for a Tesla autopilot. It'll crash somewhere. It's good enough for me. It's just a tool, right? Then I was like, okay, let me try vulnerability detection. Will this even work? Will the idea work there? Same thing, let's take the most simplest thing that everyone knows. Everyone knows reflected XSS, the age-old bug that is still feeding bug bounty people. Yeah? So, I am one, by the way, sorry. So, so when you see some markup like this, you'll just put in your payload there. And again, I don't have to tell you the beauty because you are beautiful people enough that you understand that you subconsciously know the context, that it is in a string context. You have to go out into the execution constant, let run the shit here and there, and then let's pop some alert boxes, and let's make a POC in Firefox. Why? Chrome won't work. So again, using RL itself, how do you represent this state is basically divide it into, basically tell it that, okay, you are inside a div tag, you are inside a class or whatever. You can give it the direct text and use some vectorizer format, but that's a very bad idea. It'll take ages to train. You tell it specifically that, okay, this is the HTML markup, dude. You just basically tell the basics of markup, saying that, okay, you are inside this context. You seem to be inside a div tag, inside a class attribute. You just tell it this. It gives you fancy stuff. So these were the enhancements I did. Basically, I restricted it to saying that, okay, only use HTML tags and stuff. And then you can easily train it to this area where, for example, let's take this injection point, like you have an injection point inside a button tag. When there are no conditions, the immediate thing that it comes up with onClick is equal to, popup is equal to 1, basically, that put an onClick attribute handler. Then I said that, okay, your state is not this dude, you cannot have user interaction. That is what Mario does, right? No user interaction, cure Xmas challenge, solve it, cure. So then might be filtered out by other stuff, whatever firewalls or everything you have. Then it was like, okay, I'll use a slash. Well, how did it learn all this? Nothing, just it had plain HTML. I let it experiment on its own. I had bunch of random syncs, and I was like, learn whatever you want to, just put in valid markup. I gave it a Selenium browser handler, and I was like, look, whenever you get a pop-up, you're in the right state. You have positive reward. Then it learned for 15 days to arrive at this. Yeah, 15 days. We were like popping shells in 2 hours. Then no space, no scores basically. And then we were like, no user interaction plus no load. There is a video if you want to watch. It's a bit long, but basically the whole idea is simple. I give it 2 forms. One form where there are no restrictions. It'll just breeze through. And the second form where it has some restrictions, it understands the restriction and then places the new payload. Once the slide deck is out, I think you can watch the video. It's actually very long. Why are we doing this? Why are we not just brute forcing? This can find payload in 3 attempts. Why? Simple, 3 attempts. Brute force, you never know how many attempts. Do I think this is smart? Not really. For someone who is in InfoSec for quite some time, this is still very dumb. I'm trying to take it to the next level, but yeah, I'm open for ideas on how to approach this problem. So what did we look at during the entire talk? First of all, we tried, the basic feature was to emulate human behavior on web. Yeah, identify inputs, understand feedback, perform sequences. Do you think this will make a good crawler? It should basically, like depending. So, but the thing was, when I developed this framework, it was all individual modules. That is because I can integrate whatever module I want into anything I want. I don't want to develop a full, so if you are planning to build a full AI, machine learning, whatever mashup, and make it sit in front of a computer and work, no, that doesn't work. Web is too complex and we have too much knowledge and we are way smart. So when someone talks about machines overtaking us, I'm like, yeah, I know. It just doesn't work like that. Yeah. Then these are the other two nice approaches that I'm aware of. One is being followed by MBSD Japan, and the other thing is they have a booth here, CloudSec. Both of them basically being companies, they might not reveal the data and stuff. I am like free kid, giving away everything. Yeah. How to get started? This is one of the most popular questions I get asked. You can get started very easily. Just click on one of those links. You will be starting in one direction. Or you can just pop up to me. I can tell you what to do. I can just, no, we can share knowledge. I cannot tell you what to do. Thanks to all those people, you have no idea what machine learning is without data. Sleepless nights, labeling stuff, it's painful. Doing it alone is very difficult in terms of data. Like you can always try lots of stuff. So doing it alone has its own advantages. Like I can just try whenever I want to and do whatever I want to. But the thing is, the main part is data. Like I really wholeheartedly thank all those people who install the add-on, because basically when you install an add-on, being all of you hackers, you understand, right? When you let a person have the ability to run JS in your browser, it's scary. I wouldn't have done that, but there are very nice people who did this. And then, yeah, the company I work at, all cool people. Shout to all of them, nice people. Then questions. It's like the other slide, lots of like minutes of awkward silence. Yeah. I have a pretty good crawler that can crawl. Okay, so the question is, what is the state I am at? I have a full-fledged crawler that can crawl good sites. For example, Twitter and stuff, it can crawl. Yeah. Filling forms is easy once you have lots of data. That is what I understood.
And about the time duration that it takes to complete all the sequence stuff?
Sequence, it depends on the sequences. Yeah. Once it is fully trained, for training it takes time. I had to spend around 1 month for training one particular sequence. But yeah, once it learns, it's a matter of it will just try to pick the optimum characteristics. Well, if it doesn't find out, it'll ask you. It'll say that, okay, I think I missed out on this one. Can you tell me, is this something new? Is this out of syllabus? Then I'll be like, okay, maybe this is out of syllabus. Let me tell you how this works. And then it will be like, okay, let me, what do you say, by had this overnight. Tomorrow I'll be up. Okay.
And about the vulnerability detection part?
Vulnerability detection is very, reflected access is very naive, first of all. The other thing is, there is a nice approach that CloudSec does using a proxy mutator and stuff. And that is a good approach. This access detection, I did it with RL, MBSD did it with LSTM networks. These are two different approaches to the same problem. Both of them work, but nothing more than reflected accesses. Like, I'm trying to make other states, but the representation part, I'm stuck at the representation. Precisely why I want more inputs, like domain-specific inputs.
So the question is, you have a crawler, but how it is tackling the captchas?
Okay, no. That's a different problem. That cannot be. So what generally happens is I had to add a proxy action. For example, in the RL agent, right, it has an action saying that take human input. But
it will need to have a human interaction for bypassing that.
No, yeah, bypassing captcha, yes. It will stop at that place and it will be like saying, okay. Bypassing captcha, there is good research on bypassing Google captcha. Like that's out of scope for what I do.
For reading images and all, that's it currently.
Yeah, but it's out of scope. Like I don't want to deviate at this moment, because if I deviate, I'll end up at somewhere else. It's a very nice topic. Computer vision it's bloody amazing.
Sure. That's
yeah. Oh, I think that's it. Any more questions? I'll take off. Yeah. Thanks.